example 5. It's a cantilever beam, as shown here. Consists of a section with a constant EI. For the loading shown here, determine the beam deflection at point C. Well, here is the point C. Okay. So this case, of course, according to a normal step number 1, we need to split the loading into 2 or more simple loadings. But actually here we cannot further split it since it's already a simple loading. But unfortunately in the table we cannot find any case exactly the same as the loading distribution. So we cannot find an easy equation to solve the problem. So here in this case we're not splitting it, or we're doing subtraction. Okay, so first of all we consider the first beam, beam 1, as a cantilever fully loaded by the distributed load W. And then we subtract beam 2 from beam 1, then we get the distributed load as shown here. Okay, in beam 2 we have the distributed load W covering only the first half of this cantilever. So in beam 1 everything is easy. You had a cantilever beam and loaded by distributed loading W. So the delta C1 will be calculated directly from the equation available in the table. That is WL to the 4th over 8 EI. This is our here, equation 29. And in beam 2, so first of all, this is very similar to our example number 3. Well, first of all, you can calculate the deflection at the mid-span here. Well, this is delta 2 or delta B. Delta 2 equals delta B. You will be able to calculate another slope. You calculate the slope at this point, and we call it delta 2. Right. So after that, you can draw the bending moment diagram. So you will see that on section BC, you have no bending moment, so BC will not be bended. It will keep the shape of a straight line section. So here, your slope will be theta equals theta 2. Here you get a triangle. So you can calculate the additional deflection from this triangle. Then you add this deflection to the delta 2, so you get the delta 3, the overall deflection. So here the delta 2 equals delta B equals negative W, the same. We will use equation 29. The only difference is that the L will become L over 2 to the 4th, 8 EI. Here it will be negative WL to the 4th over 128 EI. Then we can calculate the theta 2 based on equation 28. Right? So in this table you can see that this equation here, 28. It will be negative W L cube, but here the L is L over 2 cube over 6 EI. This is our equation 28. And it equals negative W L cube over 48 EI. Then here the delta 3 as denoted here. Delta 3 equals delta 2 plus, we just look at that triangle. that will be half L by sine theta 2. And the delta 2 is negative WL to the fourth over 128 EI minus L over 2 by, if we assume that theta 2 is small enough, so the sine theta 2 equals theta 2, right? The WL cube over 48 EI. This will be negative WL to the fourth over 128 EI minus WL to the fourth over 96 EI. Okay, then the overall delta point C equals delta C1, since this is a subtraction, so minus delta 3. Okay, so important to note that here is a minus, not plus. Okay, that's it.